The periodic law. Basically, it's this idea that in the periodic table, that columns on the table have elements of similar properties when they're laid out according to increasing atomic number. And this is called the periodic law. And each one of these columns, these groups, as we say, has been given a name. And we're going to go through these, talk a little bit about the properties of each, and then move on. Alkali metals first. Of all the metals on the table, these are the most reactive. You'll notice that hydrogen is not a part of this group. We see that it is in column 1 right there, but it's not a metal. It starts with lithium, and we work our way down to francium. They are called soft metals because you can cut them like you could cut a stick of butter. They're very easy to cut. They're very reactive because of something called valence. And valence simply means the outer electrons in an element. These have a valence of 1 electron. And what that means is that the next lower level of electrons is a full outer level. So if they lose this 1 electron, they become very stable. And that's what elements are there to do. Their goal in life is to become stable. So lithium through francium, they want to lose that electron so that they can become stable. They are extremely reactive with water. We'll do a demo in class. Perhaps I'll put it on the channel of sodium being put into water. And as you go down, it gets more and more violent, the reaction with water. And they react with the water to form a base. So if you put sodium in water, you get sodium hydroxide. If you put potassium in water, you get potassium hydroxide, and so on. So they are the most reactive metals on the periodic table. Oh, and they're soft metals. We already mentioned that, but I forgot to click it. Sorry about that. Next over, you have the alkali metals. And the alkali metals are this column here. And we don't have to omit any elements here because hydrogen is shifted over one place. So beryllium, magnesium, all the way down through excuse me, mistake. There we go. Alkaline earth metals, excuse me. The alkaline earth metals are the metals that are just to the right of the alkali metals. They are also reactive, but not as reactive as the alkali metals. And they're a little harder, so they don't cut quite as easily with a knife. They still do cut, but you have to press a little bit harder to get them to cut. Beryllium through radium. Barium is used in a lot of medical diagnostics, specifically looking at the digestive system. You can ingest barium sulfate, which coats the inside of your esophagus or your colon, and then they can x-ray and see if there are any problems. And of course, magnesium, very light metal, can be used in things like airplane wings. Magnesium can be found there. So if you're comparing the two alkalis to alkaline earths, alkali metals are much more reactive, but alkaline earth metals are reactive as well, just not as much as the alkali metals. All right, let's move on. Transition metals, as you can see, the transition metal area covers quite a large area. So we don't say that it's just one group. We say that it's a bunch of columns, but we still call it a family, a group. And it's all the way around here. These are all considered transition metals. And the reason they're called transition metals is because we're moving from very metallic type of properties over to the nonmetals over here, non-metallic properties. So we're transitioning across. These are much harder than the alkali metals or the alkaline earth metals. So you're not going to just take something like a titanium and cut it with a knife. So they're much harder metals. They're also less reactive. They have varying valences, but they are not reactive. So sometimes they're called the inert metals. If you think about a lot of the elements like gold or silver, some of the precious metals, we wouldn't want those reacting if we were washing the dishes or something. So when we put them in water, nothing happens. They're very, very inert. And they also tend to form compounds that are colorful. So you'll see a lot of these types of elements in various paints. The one that comes to mind, lead iodide, and lead is actually shifted over slightly, so it can't be officially a transition metal, but it's still an honorable mention member. Lead iodide is a yellow substance. Of course, it's not used in paints anymore because lead is poisonous. But copper sulfate, a blue solid. Iron oxide, which is what rust is. There are a lot of compounds that are colorful because of the electron structure in the transition metals, which we'll get into later. Groups 13 through 16, we really don't have a specific name for each group other than it's named after the element at the top of the group. So this is your boron family, this is your carbon family, this is your nitrogen family, and this is your oxygen family. And as you can see, because of the color coding, we have a lot of variety going from left to right and going from top to bottom. A lot of change is taking place. These green areas are your metalloids. The blue are still your metals, sometimes called the poor metals, because they are not as metallic as their neighbors on the left. And then you have your nonmetals in yellow. So there are specific names for these, but our book and our class, we're just going to call them by the top element in the group. So boron, carbon, nitrogen, and oxygen families. And just a very wide variety of properties here. The halogens, they are the most reactive non-metals, and fluorine is actually the most reactive element on the periodic table. We talked about valence earlier. Well, these guys have a valence of 7 electrons, and the magic number is 8. So really all they need is one more electron, and they are happy. So when you have a halogen coming together with an alkali metal, like lithium coming together with fluorine, and you get lithium fluoride, they make a perfect pair because the lithium wants to give up the electron, the fluorine wants to accept the electron. And of course they have to give up their identity, become a compound, but they both have reached stability. So halogens are the most reactive nonmetals. Astatine, you'll notice that it's a metalloid in our book. I've seen lots of information that categorize it as a halogen, only because our book categorizes it as a metalloid. We're going to keep that. You could just, if you call it a halogen, that's fine. You're not wrong by saying that, but we're just going to go with metalloid in this class. Halogen bulbs, like in cars, have iodine in the filament. That's where we get the name halogen bulbs. That word halogen actually means salt former, because when they react with metals, they form salts. And of course, what we already mentioned. Group 17, most reactive nonmetals. All right, that's part 3 of the periodic table. We'll get part 4 up here very soon.